Alright everybody, just wanted to record a couple more videos for pre-calculus. So the first video that was requested was problem number 11 on level 4. So this says sine to the fourth of theta minus cosine to the fourth of theta equals sine squared theta minus cosine squared theta. Again, remember, I always start the proofs by identifying some identities that might be used. We don't have any identity for sine to the fourth. We don't have any identity for cosine to the fourth. Sine squared and cosine squared, we do have an identity, which is sine squared x plus cosine squared x equals 1. So when I look at this, I also need to try to find which side is more complicated. To me, the left side is definitely more complex than the right. It's got these fourths. And when I look at this, I remember that we learned something called the difference of squares, which says that a squared minus b squared equals a plus b times a minus b. In this case, this is really sine squared squared minus cosine squared squared. So this side can be factored into sine squared of theta plus cosine squared of theta times sine squared of theta minus cosine squared of theta, and that, remember, still equals, we haven't done anything to the right side, so it still equals sine squared theta minus cosine squared theta. I now use my identity, sine squared plus cosine squared equals 1, so I've got 1 times sine squared theta minus cosine squared theta equals, again, remember, we haven't done anything to the right side. This is proof. We only work with one side of the equation. 1 times anything is itself, so I've got sine squared theta minus cosine squared theta equals sine squared theta minus cosine squared theta. And there we go, and that is the proof for problem 11, level 4.